So when we do this problem, it says that the initial velocity of the project, that's the question. What is the initial velocity of a projectile? So what are they referring to? Okay. It goes a horizontal distance of 570. So it starts here, ends up here, right? So my first initial position is 0 meters. My final position is 570 meters. It does that in a total time of 9 seconds. And so I have this projectile. I don't know what it is, but it just kind of goes through the air like this. By the way, that shape is a parabola. Oh shoot, I don't want that. We'll just do this. All right, so that's the shape. And the question that they're asking us is, what is this velocity? What is the initial velocity? Well, you're right if you said, okay, well, let me just start figuring out what I know. I know that the velocity in the x direction is equal to the total distance divided by time. Yeah, that's true. And if we do that on a calculator, 570 divided by 9 is about, whoops, somehow I did something goofy there. It's about 63.3 repeating, so I'm just going to say that's approximately 63. It's not approximately, it's exactly that. Meters per second. So I know this. That's 63.3 meters per second. But what I don't know is the y value. I don't know the initial velocity, right? So also we should probably mention that this is the initial x velocity. Well, why do I need to know that? Well, at some point way over here, I'm going to need to plug that in. I'm going to have to say that my velocity v initial is equal to the square root of v sub x initial squared plus v sub y initial squared. So in order to actually find out this initial velocity, I've got to find v sub y. All right, so let's do the work for the y. What is the initial height for y? 0 meters. What is the final position for y? 0 meters. So if I come down here, there's an equation, y equals y naught plus the velocity in the y direction initial times the time. Do I know the time? Yep, there's the time. It's the same for everything. Plus 1/2 times the acceleration times the time squared. Oh yeah, I probably should mention that the acceleration due to gravity is 9.8 meters per second squared. Per second. Whew, that's a lot of work. So I got 0 is equal to 0 plus. Now I'm going to flip-flop this. Normally I would plug in 9 for t but I'm going to say 9 times v naught, right? So I'm just kind of switching the order of the variables. That's okay. Plus 1/2 times negative 9.8 times the time squared, which is 9 squared. All right. So I've got 0 is equal to 9 v naught y. Let's do this on our calculator. If I say 0.5 times negative, negative 9.8 times 9 squared, I get negative 396.9. I'm going to add both sides to both, or add this to both sides. Because now I just got to solve algebraically. So 396.9 is equal to 9 times Vy naught. Divide by 9. Go back over here. Huh. 396.9 divided by 9. 44.1. Okay. So now I just plug that in over here. That's it. So to finish this, I say V naught is equal to 63.3 squared plus 44.1 squared. We'll plug that in our calculator. I'm going to do a bunch of 3's just for the funsies. Plus 44.1. And it's about 77.1. I will make it 77.2. I don't know. All right. Was that close to the answer? Yeah, 77. And I think that was the last question on the test, right? That's a little bit of math.